today I'll be presenting our work high model generating nice and sweet of good is not as bad as rice towards context and semantic infused dialogue generation and loss function and evaluation metrics. On behalf of all authors, this work has been done in collaboration with IIT Patna, University of South Carolina and IIT Bombay. This work I carried out during internship at AISC. So, um, while working in dialogue generation field, I observed something to very unusual as what we do in a real world. For example, this is a simple encoder decoder model. If you see, given a context, it has to generate the current response, and let's say the goal response is the Taj Mahal is fantastic, and it has generated the Taj Mahal is superb. Let's say response 1, the Taj Mahal is, and the third one is like a magnificent, majestic and iconic. So while in traditional model, if you do how losses get back propagated is the cross entropy, which gets back propagated there. So if you calculate the cross entropy here, what will happen? It do word to word matching. So for example, for this example, the Taj Mahal is superb. So if it has to do the cross entropy here, if you see the only one word is not matching as it is from the goal, which is fantastic. So here it is superb, but in the second scenario also it is the similar, like Taj Mahal is while the response is completely meaningless and useless, it gets quite less loss compared to the other one, because the reason is the cross entropy loss function is word centric or the token centric, while in a real world we care more about semantic, whether you say a same word or not. If it is very much similar to the notion of the actual word, it works, right? But here it doesn't work in that way. This is one scenario. Another scenario, if you see the two people is talking, and then the same, if I come across for the evaluation metric, again the evaluation metric whatever we have in general is the blue rules metric. These are mostly word to word matching they do. So for example, here it's a magnificent, majestic and iconic, which has not a single overlap with the goal sentence, which is the Taj Mahal is fantastic. You will see that it gets the lower score compared to anybody else responses here. But this is not the true scenario. The response magnificent, majestic and iconic is a quite good response, and can be taken as a viable response, but here it gets the quite less score. So these were the two problems that we observe. One with the loss function, that the loss is token centric and it is somewhat missing the semantic part, while loss calculation and back propagation. Second is the evaluation metric, where we are again giving more weightage to the token centric or the word centric. Cannot we do semantic more into the context? So these are the two problems that motivated us to work on this problem. So the first one was the fixed target problem. So fixed target problem is that in traditional system they try to match as it is with the goal response. That is the fixed target problem. Context relevance is that given a context there could be multiple response could be viable, right? So it's not necessary to match exactly with the goal. You also need to consider the context into account, but usually the cross entropy or any popular dialog generation loss function doesn't consider this property. So we thought of investigating this property into dialog generation loss function and see how much it impact, right? So this was the whole thing that we carried out for this work. So how can we overcome the issue that was in our mind? So first, C loss, if you see, it's a simply negative likelihood of that word compared to the other words that we have. If in the goal we do the how much priority distribution for a given word and how much it is in the goal, and we see how much difference it is there, and then finally the summation of log likelihood we back propagate negative log likelihood. So we thought of why not we also put here the context into picture. What does that mean? Along with the whatever it has generated cannot do with how much it is, appropriate as per the context. That was in our mind, first thing. And second thing was, in order to solve the fixed target issue, can we do something like ground, means whatever it has generated, and the second one is whatever we have, means the goal response or the ground sentence, whatever we had cannot be the semantic part as well. So finally we were thinking something of a loss function, like cross entropy, some factor into whatever we thought of context and semantic. Because cross entropy is very important, because if we don't use it, it will lead to the cold start problem, right? So it needs to be grounded with some metrics, and C loss do quite well, so we cannot remove it completely. So we thought of putting alpha into beta factors and a weighted metrics for that as well. So this is what we propose, a new dialog generation framework. So here what happens, if you see, for example, you have encoder decoder model. It can be decoder only model, so it's not required to be encoder decoder architecture. So for example, this is the same context here, hi, it's so and so forth, and then finally encoded sentence is going to the decoder. Usually in traditional system, what happens, whatever generated tokens probability we have and the goal utterance we have, we calculate the C loss and back propagate. But in this proposed scenario, there is a bit of difference. What is the difference is that along with this C loss, we also putting one another component from here we are getting semtextual log loss, and then finally we are back propagating. Now let's see how this has been calculated. So let's say we pass this context to the decoder, and finally decoded a response, and that response we pass it to the context relevance module, which takes that generated sentence as well as the ground context and see how much it is relevant, whatever it has generated. And then similarly for the generated sentences passed, and it has been checked with the goal sentence, how much semantically they are close. And when these two are combined, context as well as the semantic, we call it as a contenic score. And that contenic score is what we want our model to predict, that is baseline estimator. Because it is a learnable parameter. Initially thought we cannot we put the BERT score like that for these two, but it didn't work, because finally it was becoming a feedback which is not a parameter of that model. So that is why we build here baseline estimator, which is just mimicking to predict contenic score. This contenic score, given the goal, given the generated and goal utterance, it has to predict what is the contenic score it will be, and then this contenic score that it has been, it will pass to the semtextual log loss, which will combine C loss plus this context and semantic factor into the account, and then it will get back propagated to the model. So yeah, this is how it works. So this 7 line you are seeing, which is passing gold, is going to the baseline estimator. So there is a mistake. It should not be the 7. It should be the generated token probabilities. So this will be, there is a mistake around that. So that's fine. We thought we introduce a new framework to do how loss should be calculated, but also we included another evaluation metric into account, because when you see all the existing metrics, they hardly consider context into account. Some of them consider semantic, but and some of them also consider world knowledge, but none of them consider all of three. And we thought of cannot we combine at least context and semantic, because world knowledge was not handy while we were doing experiment. So we thought of combine this context and semantic. So CR plus SR means context relevance, plus SS means semantic similarity. So we are passing delta factor with that, so that we are giving a weightage to that. If you see chit chat scenario where context matters not much, given whatever it has to be generated, entropy used to be very high. But if you see the task oriented setting, each response is to be very close to the previous utterances, right? So here entropy is quite less. So this CR and SS mod depends on the nature of the dataset we have or the nature of the dialog setting we have. So in case of if it is a persona based setting or it is a chit chat setting, these modules, this weightage should be high. So this is the parameter that evaluation metric get it out of it. We experimented with on the two data sets. One is task oriented in nature, which is multi-OS 2.2, which is a kind of a largest task oriented and very well known in the community. Another is the persona chat, which is chit chat setting. We experiment with both the data set to understand the proposed loss function and the evaluation metrics not only work for one setting but the both kind of dialog scenario. That is what was in my mind to do that. So what we found, if you see the result, so we experimented with the three different kind of architecture. One is the simple encoded decoder transformer based model, one is the GPT, and another is the llama. And all the scenario, if you see the our model, which is weighted semantic CE, means CE into weighted part of semantic we put. For example, CE loss into SS, so which is semantic similarity we put it, just a weighted matrix, and then semantic and context, so both part CE into SS plus CR. Semantic reinforcement is the reinforcement module that the proposed model we shown that finally the semantic score is reinforced to the model along with this loss function. And syntaxual log loss is the final setting where you both not only semantic but context is also reinforced to the model. So this is in every setting, if you see our model is far better than the CE loss, whether it's a GPT setting, whether it's a llama setting. And we also observe one pattern that the semantic reinforcement works quite well compared to any other setting. What does that means? It means that when you consider semantic of the generated sentence, it is way better than when you consider both semantic of generated sentence along with the relevance of that generated sentence with the context. And why it is so? The reason is when you combine both the information semantic plus context, it is giving a lot of information to the model. And models, it's there are two ends, if I say x and y. X is the starting and y is the end point, and we are trying to optimize in middle between that. So and that is where we believe that the model didn't do well for that. But when we did in terms of human evaluation, we found that the model which consider both context and semantic, it is way better than any other setting, because it was generating a very contextual as well as a semantic relevance response. This is the result on the multi-OS dataset. We did the same thing on the persona chat datasets, and we found improvement in every setting here as well. But if you see here, this semtextual log loss function means which consider both semantic as well as the context is better than even semantic reinforcement, which was a scenario, which was not the scenario in the previous slide. And the reason was that context matter a lot here, in the persona setting, because first utterance, second utterance, third utterance, this is the persona setting, let's say, and you are generating the fourth utterance. In fourth utterance can be related with the first one because it's a chit chat setting, very much entropy is high. But in case of task oriented, they are very much connected. If you are generating fourth one, it is most likely it will be connected with the third and second, not with the first usually. But here it can be connected, and that is why the context plays a role here a lot. Not only with the token based metrics, we also consider with the BERT score, which is available metrics, the embedding based metrics, and the dilution, which is not only considering semantic for the generated and goal, but also the contextual relevance of the generated sentence, right? So we found that in the both the setting on the both the data sets, our final model, which is a semtextual log loss function, is way better than any other setting. And although this improvement is in range of 0.01 to 0.05 or so, but as it is a vector based embedding matrix, it is very much significant, improving that metrics even by the 0.01 is I believe quite good, rather than comparing with the any other like accuracy and those things, because their number of levels are quite less compared to their. We did few case study that given the scenario how different loss functions are doing, and we found that the final loss function that are proposed one is the syntactial log functions. It is generating a response which is very close to the context, as well as it is factually also very much accurate to the gold one. Why it happened so? Because it has learned that context, semantic embedding space as well, some sort of key, which one should be, whether it is generating nice or good, it's both are okay, right? So if you see one scenario here, simple CE loss generated, I have two hotels in the north and one in the moderate price range. But the gold response was there are the several guest house available. Do you have a price? Do you have a price? Preference or reference, whatever. But our model also generated a very specific to that, that there are the two hotels that meets your criteria, so and so forth. Would you like to book one of these? So it could be the generic, but at least it is better than the what I say is the CE loss, which is only giving the template kind of response, but it has a very specific response to that. So overall observations were that we found that this syntactial logs were better with the CE loss in the two terms. One was the very much relevant with the context, means let's say CE loss doesn't contain the information that the people from let's say north, and but context, our model understand that part as well, and it is saying, hey, as you are from the north, and these two hotels are also in north, you should go for that. So this kind of scenario that we observe quite a lot. And the second one was semantic, which was saying, so much of variation were there for nice good has been generated, and those variation were there. It was not very much specific to it should generate to the goal, which is some sort of increasing also interesting in responses into the evaluation part as well. So coming to the analysis which we found to be shared and that could lead to the some future directions are as follows. More contextualized and consistent response, as I was talking in the last slide, that was a scenario. Second is very interesting, we found that on persona our model performance was, the range was way better than the multi-use, and we were very surprised to see that, and we tried to understand why it is the reason, and the reason was the vocabulary space. In the persona chat or in any general chit chat data sets, what used to have, we have a lot of variation around words. For example, if you see here, for good there are so many variations, nice and happy, and here these models adapt far better than where the number of variations are quite less. So that was the reason we come up with the primary contribution, which is leading it to do far better on the persona chat compared to the multi-use. We found in some cases our model repeats some words, particularly the persona entities. So this was the one problem that we observed with our setting as well. So coming to the last slide, which is a conclusion of so for any algorithm, the core is objective function and the metric. So if you are making a delta improvement there, it has a huge, because it's an objective function, it is the things which makes and breaks, right? We understand few limitation of the dialog generation loss function. That was the one was the fixed target, and the second was the context. We tried to overcome with our proposed loss function, which is syntactial logs function. Also we included a new metric called dilution, which is specifically for dialog generation. And our findings suggest that the syntactial loss function did quite better than the cross entropy, and which signifies the efficacy of dialog context and the semantic part in dialog generation loss function. So one thing which I was discussing at the initial part of the slide was world knowledge also matter. If I give the two responses to a 30 years old and let's say a 12-year-old, the most likely is the comparing them would be far better from the 30-year-old guy, because you know he has a lot of world knowledge and variation and all that. He knows how these two sentences are close to that. So we can also consider that world knowledge information, you know, in finally calculating the divergence between the generator and the goal. That would be some interesting direction to explore that we look for. So yeah, thank you so much for hearing the and understanding this this work. So I would like to thank ECML for giving me this opportunity to express our work. This is the QR code for the paper and the code, which is publicly available to access, and we'll love to engage in any kind of discussion